Thank you very much.
Artificial intelligence clinical application.
Thank you very much for this kind of introduction. While in the next 30 minutes, I will try to give to share with you some experience that we have had in our department in the last 4 or 5 years applying artificial intelligence. I will start with the general concepts, and then I will go a bit deeper in some of these experiences. Since the lecture is just only 30 minutes, I will, if any of you will be interested in more details in one of these specific experiences, I will be happy to answer your questions after all. So why artificial intelligence, why now? It's everywhere. Probably because people, it's trusting more and more on computers. Culturally, it's an acceptance that what the computers are doing, and we are facing a huge increment of the health cost. On the other side, the possibility using this concept of the GPUs, for the one that you don't know what the GPU is, the kind of computing system that are used in the video gaming, and this graphic power to compute graphics and the GPUs is becoming more and more affordable. And even the development algorithms is being more popular, digital information is everywhere, and so having aggregated information, it's more more accessible for anyone. So any one of you that has a smartphone, like my fellows here and all of you, you are in fact using highly developed artificial intelligence, even deep learning for many years. So one, from what is relevant for us, talking about images, just identifying pixels and describing a concrete image in an automatic manner. We can do it with your phone. You just put there a lion, put mountain, or put a beach. Then you can select your pictures in your smartphone. In audio, we are having asynchronous translations now. Just you dictate it in the system, you get immediately in different languages, translating from my case from Catalan. I don't know about Arabic, but for sure in French, English, German. It's available in every one of your smartphones, and even more sophisticated. It's not just identifying something, that could be even this train with these yellow tracks. So this means that using these algorithms that the machine trains themselves using the concept of machine learning, we can distinguish what seems to be easy, a cat from a dog, with accuracy that's close nowadays to 100%, with automatic learning from the machines in this case. If we think about our job and our role in our daily practice, and we ask ourselves, can a machine learn what we are doing? Well, in fact, we can teach a machine what we are doing with simple algorithms. We are doing that for many years. Can the machines themselves learn what we know and do? Certainly, yes. But the most challenging thing is it's possible for a machine learn more than we know and to extract knowledge from the data that we are not able even to see. The answer is, again, yes. So machine learning involves algorithms that can learn and make predictions based on new data that we are not able to process as human beings. And secondly, these computers can improve the development of these algorithms without any additional humans interference. And this is common in many areas, and as usual in the health system, we are not as early beginners in the use of these concepts related with IT. This is just an example of one specific setting in musculoskeletal radiology, that here you have 3 radiologies, A, B, and C, and then an existing AI algorithm that can diagnose and can detect and can process and classify the features in one image, And probably in the future, we will have this kind of classifier with a specific question, an AI, that is much over any kind of radiologist. This can be now applied for very specific questions, not is generally applicable, but is a possibility for sure in the future. One distinction to be made very clearly is if we are talking about a single neural network, I will show you an example of this kind of software that is just an algorithm. Here is not machine learning, the machine is not learning, but facilitates our decision-making process from a deep neural network where the machine is learning from itself. So looking at the future, we had a lot of time with humans programming the machines. We are starting now using algorithms more and more, and the use of these deep learning neural networks is at the corner. I don't know for how many years, but it will be, in some cases it's now, in some cases it will took several years. For you just to see how this is evolving, here you have, it's probably it's 2017, probably this group is over here, but talking just about narrow AI applications, you see in medical informatics, sensing, imaging is growing exponentially in terms of solutions. I used to say, because I used to have interviews every 2 weeks in my department with small, middle-sized and big companies offering me solutions usually for a problem that I don't have. So the situation is how to fit with the clinical questions and the problem that we are experiencing with the solution with these companies are offering us, and that's why they are suffering with not having enough resources in the moment. It's also interesting to clarify that artificial intelligence in our field can be applied in several steps in the workflow. It's not the same as the image acquisition and reconstruction for the modalities, that in terms of increase our perception and detection through image enhancements, to quantification imaging biomarkers, to increasing our power to detect diseases. And this is probably the most complicated one, is the reasoning. Substituting the reasoning of the radiologist by a machine. This is a bit tricky and has a lot of ethical issues that I will not have time to discuss today. If you think about the workflow in radiology, since where we have a request, we make a decision, we indicate the examination, we perform the examination, then we visualize the examination trying to detect disease. Once we have detected, we have to classify benign, malignant, disease, not disease. Then we have to make a report, and then we have to communicate the report. AI can be applied. We have IT in all of these segments, in these steps of the workflow, but AI can be applied in every single step of this workflow. It's completely different, an AI solution for decision making at the ordering moment than taking examination. Just for you to know that most of the MR machines, CT, and even now ultrasound are using AI algorithms in order to detect and to make it more easier. So I used to say to our technologists that be careful with the future, because since now, managing a 3 Tesla machine MR, we need a very high trained technologies. But nowadays, if we can just protocol and standardize all the protocoling, even the machine can detect the patient, can put it in the machine in the perfect manner, apply the algorithms, and then the necessity for a high tech in the operating room is not that necessary what it was in the past. So having a nice clerk smiling to the patient could be more useful than having a high tech close to the machine, because we can manage the machines even from the distance. So talking about examples in our experience, I will just go through the use of computer-aided not only detection, also diagnosis. Our experience using clinical decision support, you have had from Guy Frijard, from Lorenzo Derkig, some information about the ESR Guide program and the ACR Select program. And then the experience we are having with a company in deep learning, so working together with a company in neurovascular. Regarding the AI clinical decision, the CAD systems are located in here between visualization and detection and classification. Why would you need a CAD system? In our hospital, we're using a CAD system for breast imaging for more than 7 years. And instead of having two readers for the X-ray, for the breast imaging, we have one reader with a CAD with the same performance, and we'll publish that several times. But the reason is very clear. We are not good enough in reading, especially in screening programs, because of the poor quality of the imaging, because of the heavy workload, because we get tired, or because we have non-systematic reading, or because we have satisfaction. So, for you to understand that the one that we are using for many years of the CAD systems is what we call ECAD, is useful to increase the rate of detection, to help us in detect diseases. The XCAD, we can differentiate between probably malignant and probably benign lesions. The system we're using is close to 0 false negatives, and the problem is having too many false positives, but we can manage that. And the third one, the doctor CAD, is when the machine can make and can provide itself the final report. We are very close to have that in a very specific. When I was hearing the previous talk about the RETHIST, we are having systems that can do most of the work in doing the RETHIST in our department using artificial intelligence. So everything related with measurements will be more and more in the machine side. What applications does have come out? Many of them. We are using for breast cancer, I said, for many years. We're using for in lung cancer screening in order to detect nodules and to classify them. In colon cancer, it's often used. Lumbar spine is not cancer, but detecting disease and doing the pre-diagnosis. In prostate cancer, in order to get better results using parametric images and morphology. And I included here melanoma because I saw a software made by Microsoft that's able to diagnose melanoma from a picture from an iPhone in more than 96% of accuracy, which is incredible. So think about that. Second experience, it's related in another part of the workflow where the doctor or the referral is asking for examination, and the system can provide, he or she, an immediate response if this examination is appropriate or not. That is what we call clinical decision support. Can be clinical decision support for any kind of thing. But the one is, the one I want to introduce to you is the one that was developed by the American College of Radiology, adapted by the ESR with a common approach that we are working together with American College of Radiology. And what is a clinical decision support thing? This has been used for many, many years. This is for provoking an attack of epilepsy, probably. There's flashing. No, thank you. Though it's to use a knowledge base, whatever the knowledge base. This has been used in the military, has been used in the stock market, has been used in many, many fields. Combine it with a database. There's an engine inference that makes text and combines information from one side, from the knowledge and the database, and provides a support for a specific decision. This makes sense when you have a very complicated decision to be made by one person with a huge amount of information. This system is used to help a lot. In our field in medicine, the knowledge is the referral guidelines. The database is the database of the patients in the electronic medical record, in the health record, in the hospital information system, whatever the information is. And the clinical digital support, to be efficient, has to be fully integrated in a clinical electronic order entry in order to make the system as rapid as possible and to provide to the referral the immediate response and the point of care of the patient. So the ones interested, the system was created at the Mass General Hospital in 2004-2005, and then it evolved to the American Providence Criteria for American College of Radiology. And the idea is to have that we have in a PDF on a paper, to have it in an ordering system. Here you have the feedback where 1, 2, 3, red is not indicated, 4, 5, 6 is marginal benefit, 7, 8, 9, it's well indicated without one specific clinical setting. So we decided to work together with our fellows in America, and we created a common group of reviewing the contents. So for the European Society of Radiology was at the beginning taking care of the contents of these guidelines, and with this strange word that's European size guidelines. And we created a group of people together with the Americans, and what was the most important thing, that we have a common joint rapid response process in order when we have some problems or indications that are not fully appropriate have been changed in the time, we decided that online. For you to know that we had the first pass on the American guidelines for the group of Europeans, we found in cardiac imaging about 25% of discrepancies. And why? Not because we are that different between the Americans and the Europeans, because the cycle of renovation of the American appropriateness criteria was about 2 years. No one was using this criteria, no one, very few people. And now when renewing the guidelines, then the consensus is much closer between the Americans and the Europeans. And since when we start using the guidelines, then the kind of feedback that we are having is huge, and then the guidelines are online adapted, not in the cycles of 2 years. For the ones interested in seeing how this works, it's very easy and it's for free. You have to get the membership of the European Society of Radiology, go to the website, get into the members user area, go in here, just clicking ESRI guide. Oops. Then you have here ESRI portal, and then you can test yourself and you can test the system. In this case, I put it male, 44 years old, with a problem in the kidney, but instead of going through the service, I decide to go to the clinical problem. In this case, I'm searching for hematuria, and I select one of these hematurias in order to get the immediate feedback. And while selecting that, immediately you have the feedback. In this case, hematuria renal parenchyma cause suspected. You are supposed to order an ultrasound. This is not indicated to do a CT scan, MRI, whatever session. But if you add gross hematuria, the feedback is absolutely different. So you have to supposed to do a CT. In this case, you have information about the radiation. You have information of the relative cost. It doesn't matter if it's euros, dollars, or Egyptian pounds, because it's a concept like the restaurants, that is expensive or not that expensive. And if you want to know why the system is saying that, you have a direct link to the criteria. So just click there and you have the whole report with all of the references related with this specific topic. And if you are not convinced, or you are complaining, or you want to just make a suggestion, you can do that in the website and you can send it. As I said, this is just for trying, just to have a taste that the system is working. To be efficient, has to be fully integrated in the operating system, in the information system, and the ordering system at the hospital. To give you an idea, this is an experience from our colleague Boris Vikacic from Croatia. They started using in 4 hospitals, and what they did is they passed the system through the referrals without letting know them that the system was analyzing what they were asking for. So they found that approximately 25% of the examinations that was asked to be done, that were requested, were not appropriate at all. Just letting know the referrals that the big brother was watching, look at that. They increase the probability close to 90%. The figures, when the system is up and running, these figures has to be up to 95, 94, 95%. So it makes the difference is huge. In our department, we did the experience with ACR Select, was 4 years ago. We started, the most important thing when doing this kind of endeavors, this applies any kind of artificial intelligence approach or solution, is to define well from the institution point of view. This is not a solution for the radiologist. This is a solution for the institution, and the CEO has to be included in the decision-making process. Because at the end, it's going to be the referrals that want to use this system. And you have to be them on board for the system to be successful. We did so, a couple of meetings with the CEO. We spent maybe 4 weeks in order to translate it, to integrate the system in our requested system. And I took close to 9 months to convince the primary care doctors in our institution how to use it and to take it as their own project. Because we started with the primary care doctors. We defined it, I'm sorry, this is in Spanish. We defined the system, the workflow I showed you, this is fully integrated in our system. And here we have the figures that we had close to 90% indicated, and this low utility and marginal benefit. But what's more important is not just to decrease the number of examinations. In some scenarios, you can use that to increase the number of examinations. So we increased by 20% the number of MRIs, and we decreased the CT scans and the X-rays that were performed under primary care. So the benefits for me are very clear. We are using, in fact, guidelines, which was not the case in the past. We are reducing unnecessary radiation exposure, justification process, educational benefits. We are using at the university with the students in order to train them to order better examinations. And in some cases, in some places in the world, you can use that to justify that you are needing more technology. So last, in the part of detection, quantification, diagnosis, our experience in deep learning, remember that here is a machine who is learning for themselves, extracting more data that we are able to see. And we're working with a company close to our department. And I was convinced by them because this kind of companies used to have contests. They put a data set on the internet, on the web, in specific websites, and they have to go to this data set and try to diagnose where the disease is without any kind of information and human interaction. In this case, it's a lesion in the brain, whereas the green is well identified. The blue, very small, is over reading, and the red is under reading. So you can imagine my surprise with that. This seems to be a good thing to go. We started 2 years ago. Then we try to apply in our stroke unit for the vascular patients. And here you have 3 residents analyzing the same image in a patient with stroke. As you see, the variability, I can say that a consultant can do exactly the same thing, just using the resident, but I'm not guilty of that. And this is let's say, the gold standard. So there is a huge variation in order to diagnose the patients. And because I'm lacking of time, I would like to show how this evolved to have a tool that combines clinical data, combines different kinds of, with a CT scan without contrast. We can have the level of acute ischemia, chronic ischemia. We can rule out hemorrhage. The machine rules out hemorrhage. We can identify the clots, and now we are working in trying to identify which kind of clots the patient has in order to predict the treatment. And putting all together, we can change this, can get a sense of the prognosis of this specific patient, which makes a lot of sense in the gene-making process, for which patient has to be included, not in the treatment procedure. We're working now also in prostate cancer, trying to identify better where the lesions are in order to better diagnose and better to follow up these lesions. And I would like to say this Gantt cycle applies to many, many, many things. But if you see here, machine learning and deep learning is in here. Here is early adopters, here's the hype, where everyone is talking about artificial intelligence. We are just, well, we're still in the hype. And now we are approaching what it's called the, in the AI winters. So many of the companies are having solutions, not finding the problems, not demonstrating that applying these algorithms is useful for the patient and can be efficient even from the economic point of view. And we are closer to be here in these winters. But I'm sure we will succeed and we will have the opportunity to see solutions up and running in different fields and different conditions. So for the radiologist's point of view, it's a kind of race. For the ones that you have patients that perceive that you have a value proposition for them, or you have consolidated equipment suppliers that helps you, that's used to have in our environments, or the physicians, referrals values our contribution, I don't see any problem. But if the patients don't trust radiologists or physicians, themselves can apply that and make their own decisions. We have seen this more and more. So instead the Philips, the Gs, the Canons, we will have the Googles or the Microsofts or the other companies. Maybe they're not interested in getting closer to us, getting closer to interested in other business models. So, and there are, for sure, physicians that they don't value our contribution. It's not their fault most of the time. Probably most of the time it's our fault. So my recommendation, what we're trying to do is to improve and to move forward to more clinical practice and diagnosis be closer to our clients and closer to our patients. If not, we will be seeing more and more that our jobs will be replaced by others, using or not using technology. So as a conclusion, in 10 years, probably closer to that, I don't see that every kind of images that we are dealing with will be pre-analyzed by a machine, whatever the system, whatever the problem. In oncology, it's very clear from my point of view, in these vascular diseases, by musculoskeletal, in every single. Then, artificial intelligence, in terms of quantification, routine detection, this is going to do better than us. In fact, they are doing better than us. So, in this case, in this scenario, probably this efficiency improvement will need less radiologists. I used to say, and others have said that previously, that there's no future for the radiologists in the dark room just reading with any kind of tool. But from my perspective, it's a bright future for radiologists embracing artificial intelligence as a tool, being more efficient. And what we are saying, that the increase of number of examinations that needs our support and our contribution is increasing dramatically, and we don't have radiologists enough. One of the biggest problems we have, at least in Europe, is the shortage of radiologists. So this kind of combination for the future is, for this kind of thing, the centaur effect, the man-machine combined, I think is the future for most of us, or probably the youngest than us. Thank you very much for your attention. We're happy to answer questions.